This call is now being recorded.
Okay, welcome back. Okay, so we will continue with 3.3, the third subtopic, the variations of resistor with the temperature. Okay, so in our previous subtopic, we know that our resistance is directly proportional. Okay, directly proportional to the temperature. Okay, it depends on the temperature. Okay, so when a temperature increases, the number of free electrons per unit volume in the metal remains unchanged. Okay, so metal atoms in a crystal lattice vibrate with a greater amplitude. Okay, why it vibrate with the greater amplitude? Because the temperature is increased. Okay, it receives an energy and cause the number of collision. Okay, so it will cause the collisions between the free electrons and the metal atoms increase. So therefore, the resistor in the metal also will increase. Resistor meaning that it will oppose the flow of the current. Okay, dia macam satu halangan. So when the free electron is vibrating, when the current want to flowing through also become a bit difficult. Okay, when the temperature increase. Okay, so we can say that our resistor is directly proportional to the temperature. So when the temperature increase, it will cause the vibration. So the vibrations and the collision will cause the current become difficult to flowing through. Oh, that's why the resistor become higher. Okay, it will increase the resistor. Okay, next. Okay, temperature coefficients. Okay, so the temperature coefficients of resistivity, alpha, okay, alpha is defined as the fractional increase in the resistivity of the conductor per unit rise in the temperature. So we can write as the alpha, okay, is equals to change of resistivity over initial, okay, or initial resistivity times change of temperature. Okay, change of temperature. Or we can write it as our resistivity is equals to initial resistivity times 1 plus alpha delta T. Okay, so this is the equations for resistivity. Okay, if you want to calculate before the temperature and after the temperature is increased, what is the resistivity? Okay, we want to find the changes. Okay, so meaning that this is the initial. I naught is the initial. I naught is the initial. No, sorry. Your rho naught is the initial resistivity. Okay, and your rho here is the final. Okay, so we are referring this is the remaining the final resistivity. Okay, and the unit for alpha is per Celsius or per Kelvin. Okay, the resistivity of the conductor varies approximately linearly with the temperature. Okay, so we can also say that because your resistivity is directly proportional to the resistor, because the resistivity is equals to R A over L. So we say it's directly proportional to the resistor. So we can also write the resistor with the temperature. We also can write it as R equals to R naught. Okay, actually similar like just now the equation 1 plus alpha delta T. Okay, so it actually depends on the temperature as well. Okay. Okay, we go to the example. Go to the example. Okay, then only you will understand. You will understand more. Okay, a copper wire has the resistance of 25 milli at the 20 degrees Celsius. When the wire is carrying a current, heat is produced by the current cause the temperature of the wire increase by by 27 degrees Celsius. Okay, and they give you the coefficients of the resistivity is alpha. Okay, so meaning that initially when it is 20 degrees Celsius, your resistor is equal to 25 milliohm. Okay, so the temperature increased by 27, meaning that 20 plus 27, meaning that your delta T is equals to 27 degree. Okay, so when at 47 degrees Celsius, okay, at the 47 degrees Celsius, okay, what is the new resistor? Later they will ask you to find. Okay, the first one, calculate the change in the wire resistor. Change in the wire resistor, meaning that we want to find perubahan. Okay, we want to find the change, not the final. If final, this is the final. But if change, meaning that we want to find the difference between the initial and final. So we can write as our R equals to R naught, okay, 1 plus alpha delta T. Okay, because the question say we want to find the changes. So we take our final, okay, maybe we can take out R naught plus R naught alpha delta T. Okay, so this one we shift to the other side. So you will get R minus R naught equals to R naught alpha delta T. Okay, so R minus R naught is actually final minus initial, and this is actually our change of the resistor. Okay, so you substitute R naught is 25 milli, power of negative 3. Alpha is the resistivity coefficient of resistivity, 6.8 times 10 to the power negative 3. And the change of the temperature, we take 27 because he say increase by. Okay, not increase to, is increased by. So meaning that this is our delta T, not T final. Okay, so we substitute 27. So finally, you will get 4.59 times 10 to the power of negative 3, and it is ohm, because it's resistor. Okay, so we find the initial and the final. Okay, and if the question asks the change, meaning that we wait to take final minus initial. If the question say what is the final, so you just find out the R. Okay. Okay, if the original current is 10 milliampere and the potential difference across the wire remain constant, what is its final current? Okay, what is its final current? So we want to find the final resistor first. Okay, because V equals to IR. Okay, if the final current we want final, meaning that your R you also must take R final, and also V is constant. Okay, so V just now is equals to, okay, V is constant. Okay, maybe later we need to find first. We need to find. Okay, so V initial equals to I initial is given or not? I initial is not is given. Okay, initial. Okay, original current is I initial, and then this is your R initial. Okay, so I initial is 10 milli, and the resistor initial resistor is 25 milli. Okay, so meaning that your initial potential difference is 10 times 10 to times 10. Okay, so initial is 2.5 times 10 to the power of negative 4 volt. Okay, so this is the initial. Okay, so the question say the potential difference is constant. So the final also 2.5 times 10 to the power negative 4. And I final is the value that we want to find. But before that, you must find what is the final resistor. Okay, so we must go back to just now okay, just now we know that our change of the resistor is equals to R final minus R initial. Okay, so we can calculate 4.59 times 10 to the power negative 3, and R final we don't know, but initial is equals to 25 milli. Okay, so our R final is equals to 4.59 times 10 to the power of negative 3. Okay, plus 25 milli. Okay, so your R final is equals to 2.96 times 10 to the power of negative 2. Okay, then only you substitute the value, okay, inside here. Okay, so you substitute 2.96 times 10 to the power negative 2. Okay, so your I final, okay, you will get 2.5 times 10 to the power of negative 4 over 2.96 times 10 to the power negative 2. So you will get 8.45 or 44 also can, times 10 to the power of negative 3. Okay, and the unit is ampere. Okay, so this is the new current flow. Okay, so if you observe, when the temperature increase by 27 degrees Celsius, what happened is your final resistor increase, right? Because initially it's 25 milli, now become 29.6 milli. Okay, so your resistor is increased. So when the resistor increase, if you refers to the current initially is 10. Okay, initially is 10. The current initially is 10 milliampere, now become 8.44 milliampere. So your temperature, not the temperature, when the temperature increase, resistor increase, and at that moment your current will reduce, meaning that the current flow will be less. Okay. Okay, next one is example number 6. Okay, example number 6, this is your homework. This is your homework. Okay, so please do it and then send it to into the Google Classroom. Okay, so we can roughly go through first. A wire coil has a resistor R initially at the temperature 80 degrees Celsius and the resistor of 7.2 ohm at the temperature of 30 degrees Celsius. So what is the temperature coefficient of the resistor at the 20 degrees Celsius? Okay, so meaning that our case number 1 is every time we start from 20 degrees Celsius, every time. Okay, so meaning that when you are, when this is at 20 degrees Celsius, this is your R naught. Okay, when it is your at 30 degrees Celsius, this is 7.2 ohm. Okay, and when it is at 80 degrees Celsius, your resistor is 8.0 ohm. Okay, so this is the questions. So we must compare. We must have, we want to find the alpha, the coefficients of resistance. We want to find alpha. So what should you do is you must do two equations. The first equation is between 2 and 30. Okay, the second equation is from between the 20 degree with 80 degree. Okay, so we will have two equations. Okay, from the equation R equals to R naught 1 plus alpha delta T. Okay, so the first one is from, the first one is between 20 degrees Celsius with 30 degrees Celsius. And the second equation is for the initial 20 degrees Celsius and with the 80 degrees Celsius. Okay, because usually we must start from 20 degrees Celsius. Okay, so you must start from everything from 20 degrees Celsius. Then only you have two equations and you have two unknown. The first unknown is R naught, the second unknown is alpha. Okay, then only you do simultaneously. Okay, so that's all for today, class. We will continue with the next subtopic in the next video. Thank you, class. Remember to send your homework in our Google Classroom. Thank you and bye-bye.